All right, so now that we have our articles in the database, we can proceed to extracting business signals from them. Now, in theory, we could just go ahead and move to the extraction step. In practice, we're going to get better results if we perform a quick triage first. So the triage is going to simply decide whether an article is likely to contain relevant business signals, and then either keep it for further analysis or discard it. That will give us higher signal for the next step and also significantly reduce costs, since we can expect to discard roughly half of the articles in the triage step. Now, since we're dealing with a fairly large input here of up to 1,000 articles, we need to be pretty efficient in sending those up to the agent to get them processed. We can employ batching. So what I found works well is to process up to 40 articles at once in a single batch. And that means if we have 1,000 articles, we would need to process 25 batches of 40 articles each. You can experiment with this number. There's no hard and fast rules here, but 40 works well for my pipeline. So we'll split these up, process one batch at a time, and then store whether the articles should be kept or discarded. We should expect roughly half of the articles to get discarded at this stage. All right, here we're looking at the README file again. This is going to be the last step that comes with prompts that you can just paste in. So we'll do this here, and then I'll go over the prompt. Similar to what we did with the previous step, we're going to split this up into two prompts. The first prompt is going to create the database tables and all of that, and the next step is going to deal with the actual LLM call. So we need a new model. We're going to call this TriageDecision. This basically records for a given article whether we're keeping it or not. So the fields are pretty clear. We have a Boolean field here to decide whether we keep it. We also have a reason string that'll help us make sure that the agent is actually making sound decisions. And then in our table model, we of course have our ID, run ID, and created add field. Another thing to point out, the way our pipeline works, everything is based on database state. The initial version of the pipeline that I built actually just used JSON files and always performed one step and then fed those outputs into the next step as inputs in a very rigid way. And that worked okay, but we can get much, much better results by basing everything on the database state. That also means that the pipeline is automatically resumable if it fails in the middle, but it can also give us much better results because we can look at windows that span multiple runs. And it greatly simplifies things, actually. So the triage step can simply look up all articles from the database that have not been triaged yet, and then feed those into the triage step, process them, save the triage decisions, and that's it. It doesn't need to be smart about looking at the current run or anything like that. So in order to do that, we need to add a method to the article repository that can get all the articles that are pending triage. So that's this one here. We need a new TriageDecision repository following the usual pattern, and of course tests and a Alembic migration. So let's kick this off. All right, Claude is reporting back that it's done. Let's look at the summary here. This looks correct. So we have the triage decision based model with the fields we asked for, the triage decision model. We have the new repository method, get articles pending triage. We'll look at this in a second. We also have the new triage decision repository. We have 4 new tests, 3 for pending triage, 1 for create many. They're all passing, and the migration was applied. So this all looks good. By the way, you don't always need to do this. Sometimes I find it interesting to just scroll back and see what Claude did. So here was our prompt. I love how it writes to-dos first and then checks those off as it implements things. So it reads stuff. You can kind of see some of the individual diffs where it adds things, updates some to-dos. And then here, at some point, it actually failed with some tests. Let me see if I can find this. Okay, here we go. So It ran the tests and it actually got a failure. And then it kind of self-corrected and figured out the problem and then fixed things, ran the tests again until they passed, added the migration, ran the migration. It actually asked for approval here. Okay, so let's open up our diffs. So here is the migration. These are usually pretty straightforward. All looks good to me. Our new triage decisions table. Then in the models file, we also have our new triage decision base model with the fields that the LLM cares about. And then in the table model, the triage decision model, we have our database fields. All looks good. Descriptions all look good. By the way, it's worth pointing out the descriptions are quite important. They're not just for you as a developer. These descriptions will actually be passed as metadata when Pydantic AI, our AI framework, invokes the LLM, in this case Gemini. So it actually passes all of this along as a sort of schema, and that's how it ensures that the LLM can only respond with the right validated schema. And that's actually one of the things I love about Pydantic AI. We'll see this in action when we implement that step next time. Just wanted to call that out here. So if Claude ever doesn't generate descriptions, you'll want to ask it to fix that. Our Claude.md file should explicitly instruct it to do so, because I did run into this in the past, and that's why I added it as a guideline. Repositories should be straightforward as well. So mainly we have the get articles pending triage function. Let's take a look. So we're looking up articles. All right, I actually see a bug here. I ran into a similar bug in the past. So this is a little bit of a pattern. And that's why we're doing agentic engineering, and we're actually looking at this stuff and not purely vibe coding as a side note. So what Claude did here is note how the get articles pending triage function takes a run ID as a parameter, right? So it's only looking up articles from the current run. And then it's doing this join here and makes sure that they don't have a triage decision yet. This part is correct. However, it should not be limiting this to the current run. What I mentioned previously about the database state-based solution, right? So this means we want to be pretty dumb here. We just want to look up all articles that don't have a triage decision yet. Now, I could just take out this parameter and here as well, but then I'd have to update the place where we call this and everything. So we're going to just ask Claude to fix this. Okay, so let's try this prompt. So I'm telling it, looks good except for one issue. Get articles pending triage should look up all articles that are still pending triage, not limited to the current run. Please remove that parameter and clause. Kick this off. And there we go. There was a quick fix. So it updated the function declaration and it removed that where clause where it was looking for the run ID. And it says tests pass. We'll actually verify that. But otherwise, this looks good now. And this one looks good as well. And then we have some new tests in here. It generally does a good job with the tests. It even has a function here that makes sure that it covers all runs. So it even learned from what we asked it to. So that's great. Let's open up our terminal. And indeed, all 14 tests pass. So let's commit this to Git. All right, added triage decision model, migration, etc. Okay, so that's our database tables and models taken care of.